Hey, Math 30-1 students. In this video, what we're going to look at is something known as the chain rule. Now, in comparison to the other rules that we've worked on in this unit, most students find this to be the most difficult section. What the chain rule does for us is it helps us to take the derivative of composed functions. So if we're thinking back to 30-1, this is talking about functions like this, where h at x is equal to f composed with g at x. And so taking the derivative of this right here can certainly be a little tricky at times. Okay, so if there's a lesson that you're going to want to slow down on, this is it. Okay, here's how we take the derivative of a composed function. So a composed function, we're going to use something known as the chain rule when we have, like I just said, a function composed with another function. So we're going to take the derivative of f composed with g at x. What we get when we do this is this, and it looks really complicated in just function notation like this, okay? Times g prime at x. So f prime composed with g at x times g prime at x. I mean, that looks really complicated with all those parentheses. Here's what this really says. In words, that reads the derivative of the outside function multiplied by the derivative of the inside function. So the outside is f. So it's the derivative of the outside, f, multiplied by the derivative of the inside, and the inside is g. Okay, so in words, it's not as scary, but the application, like actually doing this, can be tricky. So let's try a couple. So let's take the derivative of this. So it's a function composed with another function. Like there's really two functions here. So the inside function is 5 minus 3x. The outside function is really x to the exponent 7. So here we go. Capital F prime at x is equal to the outside. So I use my power law. Times the derivative of the inside. The inside function that I'm composed with, the derivative of that is minus 3. And then we simplify. So minus 21, 5 minus 3x to the power 6. So not awful. Okay, that one was okay. Let's try another one here, b. So g prime at x, the outside function is the exponent. So 3/4 x cubed plus x squared minus 2. Okay, subtract 1 from your exponent. So now we're -1/4 multiplied by the derivative of the inside, 3x squared plus 2x. Now, let's do some simplification from here. So capital G prime at x, well, in our numerator, we're going to have 3x squared plus 2x. But what I'm going to do right now is I'm going to factor out an x out of that. So I'll have 3x plus 2. I've still got this 3 right here from my fraction, so that's going to go right there. In the denominator, 4, and then x cubed plus x squared minus 2 to the 1/4. Now you could write that as a radical if you wanted to, but I don't feel the need to. There we go. Okay, so everything's left with positive exponents. We factored the numerator. And again, that factoring the numerator is going to be a big deal when we get to curve sketching, drawing things by hand. All right, C. Well, the first thing I'm going to do on C, again, is I notice it's a function composed with a function. But I like to write my radicals as rational exponents. Now I take the derivative, so y prime, derivative of the outside is 1/4. So x squared plus x, subtract 1 minus 3/4, multiplied by the derivative of the inside, that's 2x plus 1. And then to simplify, I'm going to have the 2x plus 1 in the numerator. The fraction 1/4, there's my 4. And now what I'm going to do, and I'll write this one as a radical, why not? It's the fourth root of x squared plus x cubed. Look at that nastiness, right? There it is. There's the derivative of that one. Okay, one more, friends. So y is equal to all this stuff raised to the exponent -3. So take the derivative of the outside, which is -3. Don't touch the inside. Subtract 1. Multiplied by the derivative of the inside. So there's that power law. That's why we had to learn that right off the bat. And let's go and simplify. So that -3 is going to hang around in the numerator. 3 plus 8x, nothing to factor there. That's good news. All over, and I'm just going to rewrite this in descending order like this. Didn't have to, but I like to. There it is. Okay. And so again, what's going to happen on a little bit more complicated questions is, again, there's going to be some factoring that might go on in the numerator, which will end up leaving us with a simpler function at the very, very end. But overall, friends, there it is. That's how the chain rule works. So again, all I want you to think about is if you have f composed of g at x, it's the derivative of the outside, f prime at g at x, multiplied by the derivative of the inside. Okay, friends, almost done derivatives. All we've got left to do is we've got implicit differentiation, which definitely can be tricky, and then higher order. We're almost there.